The inverse of this matrix is given. Use this inverse to solve the system of equations. So notice the coefficients 2x, 2, negative 4y, negative 4, 1z, 1. This first matrix is the coefficient matrix. So we can write this. If we call this matrix A, and if I let x equal the x, y, z variables, and if I let lowercase b equal the answers, the constants, 3, negative 2, 5, then we could rewrite this system as an ax equals b matrix equation. Some people have this formula memorized, but you can left multiply by the inverse matrix, A inverse, if it exists, and on this problem we know it does. And that gives us really Ix, but it ends up being just x equals A inverse times b. So the x is the variable matrix, the solutions we're after. So we take the A inverse, which is given, and this takes a bit of work to find, so it's nice that this is provided for us. And we multiply by the B coefficient matrix, and this is a 3 by 3, and this is a 3 by 1, so it is possible, and the answer is a 3 by 1, which is good because that's what the x solution is. First times the first is 3 plus. Second times the second is negative 4. Third times the third plus negative 1 times 5. We have 3 minus 4, that's negative 1, minus 5 is negative 6. That's the top one. And then 0 and negative 2 and negative 5 is negative 7. And negative 3, 0, and negative 10 is negative 13. So this is our solution x, y, z in matrix vector form. We could also write this in point form, negative 6, comma negative 7, comma negative 13, or x equals, comma y equals, comma z equals. What you don't want to catch yourself doing is multiplying A and its inverse, because you'll get I and you'll be like, oh, duh, they told me it was the inverse, why did I check it? Or trying to start with the A matrix and going through the inverse process to find this. That's all wasted time. Just use the matrix, multiply it by B, get your answer.